Awesome. Thanks, Emily. Hi, everyone. My name is Luke Trowbridge. I'm a product marketing engineer here at Texas Instruments. And I'm here today to talk to you a little bit about some new isolation products that we have that have recently released. So a quick agenda of what we're going to talk over the next 30 minutes. I'll give a quick introduction to how TI's isolation works, what it's built of, how it's made, in case you're new to the topic of isolation at Texas Instruments. And once we have a feel for how the technology works, I'll talk about a couple new products. So the ISO 6.7 family, which is an effective family of digital isolators, a new family from Texas Instruments. And then I'll also talk about the ISO 1044, which is a very small footprint isolated CAN transceiver. We'll also discuss the ISO 1640, which is a bidirectional hot swappable I2C digital isolator. And then lastly, we'll talk about another integrated isolated transceiver, the ISO 1500, which is, again, a very small footprint integrated isolated RS-45 transceiver. Okay, so to start, let's talk a little bit about how TI creates their isolation barrier within their digital isolators. TI uses a capacitive-based technology built from a silicon dioxide insulation material. So what exactly does that mean? It means we take advantage of our very tightly controlled fab process, and we build capacitors into our devices using silicon dioxide. Then in many of the products, we actually put two of those capacitors in series, creating what we call a double capacitive or series capacitive isolation barrier, which really enables some pretty impressive isolation strength by doing that. So TI uses silicon dioxide for a few reasons. One, because of its inherent dielectric strength. You can see in the table on the right of the most common materials used to provide isolation. Silicon dioxide is the strongest. There at the bottom of the table, supporting about 500 volts per micrometer. We also use silicon dioxide because this material doesn't degrade with exposure to moisture. So some of these insulating materials like polyimide have the ability to degrade that dielectric strength over time as it's continuously exposed to moisture, which can bring down the strength of the barrier. Okay, to give you a better feel for how these devices are manufactured, this image on the left here shows kind of an animated X-ray of the inside of one of our digital isolators. You can see that there are two dies represented by the orange rectangles there on either side of the isolation barrier, represented by the blue dotted line. Each of those dies has the capacitors built out of silicon dioxide, providing the isolation barrier for that channel of data isolation. And then you can also see the gray lead frame there, which holds our die in place and then eventually becomes the leads outside of the package. Okay, so with that, now that we have a short introduction to how isolation works at Texas Instruments, I'll jump into some new products and specifically start with digital isolators. So these are just basic data channel isolation devices. Today I'm going to talk about the family here on the left, boxed in, the ISO 6.7 family of cost-effective isolators, but did want to mention how that fits in with the rest of TI's digital isolator portfolios. We have more than the four shown here, but in general, these are the latest and greatest devices that customers usually start their search for a digital isolator with. The ISO 7.7 is kind of the flagship product that comes in all sorts of different channel counts and packages and fits most bills and applications. The 7.8 is TI's highest reliability isolation barrier. So if you're really looking for something as strong as possible, that's the family you'll want to look at. And then the 7.0 family is focused on being absolutely as low power as possible. So it's about an order of magnitude lower power than these other devices. But today we're going to talk about the ISO 6.7, which is very similar to the ISO 7.7 family in specs, but it is focused on being as cost effective as possible. All of these families shown here do use the series capacitor technology that I was talking about before, so they all have capacitors on both sides of the isolation barrier. So jumping into the ISO 6.7 family of digital isolators, it's going to come in a couple different flavors. So this is both a 5,000 volt and 3,000 volt digital isolator family. That's going to come in both reinforced and basic isolation to the component level certifications that we certify our devices to. So the one shown here at the top is the VDE 0884-11, which is a new certification standard for 2020. It used to be the VDE 0884-10. Just a quick note, if you are looking for isolator devices moving forward here in 2020 and beyond, you'll want to make sure that they are certified to this new VDE standard. It's very important. But they're who give us the certification for reinforced or basic isolation at a component level. These devices have an isolation rating up to 5,000 volts. So there's 3,000 volt versions and 5,000 volt versions. And then they support surge ratings, so surge voltages up to 10,000 volts. 10,000 volts is what's required by VDE, the certification agency, to be able to call an isolator reinforced. So that's very important. And then they support working voltages up to 1,000 volts. And then also have really high common mode transient immunity, or CMTI. So shown here, their typical is 75 kilovolts per microsecond and a minimum of 50 kilovolts per microsecond. Some of the electrical properties of this family: the data rate supports up to 50 Mbps. That's one place where it differs from the ISO 7.7 family. If you're familiar with that one, that family supports up to 100. So if 50 is plenty for your application, then that's great. I think you can start with the ISO 6.7 family. Low propagation delay of about 11 nanoseconds typical. And then a really wide supply range here. So this new family can now support down to 1.8 volt logic and supplies, and then all the way up to 5 volts as well. It does have a pretty wide temperature range as well, so -40 to 125. So if you have cold or very hot applications, this will fit that bill. And then this family is also Q100 automotive qualified. So if you're looking for automotive applications, this will fit. So I mentioned a couple different variants. I'll just post this up here for a second just to show that there's going to be a couple different channel configurations as well as package options and automotive, non-automotive part numbers here. So the top line of the table is the 5,000 volt reinforced part that'll come in both commercial grade and automotive. And that's for both 3 and 4 channel devices. It comes in a 16-pin package. And then the middle line is for basic isolation. So if you just need, if 3,000 volts of isolation is plenty for your application and 450 volts working voltage, then we have a 2-channel digital isolator there in a small 8-pin package. And then lastly, we have some 2-channel devices coming out in a wide body package, but in an only 8-pin package, so saving you some footprint there while still supporting 5,000 volt isolation and reinforced certification. Okay, with that, I will move on to some isolated CAN devices. So in these, what happens here for isolated CAN is we take that digital isolator technology that I was basically just talking about in the ISO 6.7 or 7.7 in digital isolators, and then we add a transceiver inside the device as well. So in one package, you're going to get a isolator as well as a CAN transceiver, so integrating those two functions. So here I'm showing the ISO 1044, which is a new product that's a very, very small solution for basic isolated CAN. So again, this is certified to the VDE 0884-11 digital isolator certification, but for basic isolation. This product supports up to 3,000 volt isolation rating, 5,000 volt surge voltage rating, and 450 volt working voltage. And then again, very high common mode transient immunity. So in this case, 100 kilovolts per microsecond typical and 85 minimum. It does support up to 5 Mbps data rate, so supports CAN Classic as well as CAN FD. Some impressive IEC ESD performance on the bus pins, so plus or minus 8 kV, and then HBM ESD on the bus pins is plus or minus 10 kV. Bus standoff on this device is plus or minus 58 volts, and the common mode range is plus or minus 12 volts. And then some cool features like TXD dominant timeout protection, UVLO protection, and thermal shutdown. And then also with this family, you get that same wide supply range. So on the logic side, it can support, again, down to 1.8 volt logic and up to 5 volt logic. So just wanted to give you some scale for how small the solution is. On the top, the image animated there is in green is a solution for creating isolated CAN with an optocoupler solution. So you can see it's pretty large. You have to use a couple optocouplers, several different discrete components, as well as external CAN transceiver. And then we can compare that to the bottom left, which is another device from TI. So this would be a 16 DW package, so a larger package supporting higher isolation ratings, which I'll show in a second. And then on the right there is the ISO 1044, which is the smallest solution there for creating isolated CAN solution. When you compare that to the optocoupler circuit, you're looking at about 84% reduction in your board space. And then even compared to just using an integrated larger body package, it saves about 60% of that board space. So if the specs for the 1044 from a high voltage standpoint meet your requirements, then it is definitely going to be the smallest solution size for your application. And then I'll just briefly show this again. This table gives you a feel for some of the different devices in this isolated CAN family. The bottom line there is the ISO 1044 that we have just been talking about. But I also just quickly wanted to show the ISO 1042, which is the top 4 lines of this table. That's the wide body 5,000 volt reinforced device that I was comparing to just a second ago. So that comes in a couple different options, whether you get a reinforced certified or a basic certified version, or in a 16-pin package or a much smaller 8-pin reinforced package as well. So a lot of options for isolated CAN, just depending on your system's isolation requirements. Okay, we'll move on next to isolated I2C. Again, the idea here is that you integrate the isolation function as well as the interface. So in this case, we've added circuitry to support I2C directly with this one device. So this is a bidirectional device supporting 3,000 volt isolation. And what's really cool about these is these devices don't require a bunch of external logic in order to support the bidirectional function of I2C. So you can just plug and play with this device and save some significant cost in board space when it comes to external components. So again, this is VDE 0884-11 certified, coming in a couple different variations here, whether you need just functional, basic, or reinforced isolation. The 1640 that we're talking about today has an isolation rating of 3,000 volts and surge protection up to 6,500 volts and a working voltage of 450 volts. And then again, very high common mode transient immunity of 75 kilovolts per microsecond. So some features of this device, it does support hot swap, which is great for plug and unplug. Both the data and the clock lines of the ISO 1640 are bidirectional. So if you need a bidirectional clock, this will support that. It can support data rates of up to 1.7 megahertz per I2C, and then a wide supply range, so supporting 2.5 volt up to 5.5 volt logic there. This one is available in just one package for now, this small 8-pin package that some of the other devices were available in as well. Okay, and lastly, we'll talk about a new product for isolated RS-485. So this is the ISO 1500. So again, this is for basic isolation for supporting RS-485 and RS-422 interfaces. It supports 3000 volt isolation, again, VDE certified for basic isolation, supports 6000 volt surge rating and 400 volt working voltage. Some specs here for the RS-485, it supports data rates up to 1 Mbps and is a half duplex transceiver. As usual, the wide supply range, so this supports down to 1.8 volt on the logic side. It has a fail-safe receiver for bus open, short, and idle. And then some impressive bus I/O protection. So plus or minus 16 kilovolts HBM, plus or minus 7 kilovolts IEC contact discharge, and 2 kilovolts IEC fast transients. Again, this is part of a bigger family of isolated RS-485 devices. So on the top line is the ISO 1500 that we were just showing. And then the bottom two are some families of devices that are available if you need higher isolation ratings or some different RS-485 specs. So these support higher data rates, both half and full duplex RS-485, and then higher isolation voltages. So 5000 volt isolation, surge ratings up to 10,000 volts if you need reinforced isolation, and come in this larger package shown on the bottom left there to support those higher isolation ratings. Okay, so that covers the new products that we wanted to discuss today, but before we move on, I did want to mention some new resources that we have as well that have recently been published to TIA.com, helpful for some of the topics we were just talking about here. So the first two documents here on the left, I just wanted to mention because these are new and help you with the conversation of upgrading from optocouplers to digital isolators. So if that's something that you're interested in, if you're used to using optocouplers and are ready to hear about the advantages that digital isolators can bring to your design, these two documents go through just some of the high-level comparisons between the two technologies and how they work and what the differences you should expect between them. And then kind of a guide for what circuits look like for I2C, SPI, UART, communications like that when you compare an optocoupler solution to a digital isolator solution. The middle document here can be really helpful if you're ready to pick out a digital isolator and you don't know where to start. This can kind of guide you in the conversation and get you to the right product family and the right device ultimately. There's a lot of different options out there and with different levels of certifications, and it can get complicated. So this can help you narrow down that conversation. And then the last two documents talk in more detail about the two isolated transceiver devices we mentioned earlier. So the isolated RS-485 and isolated CAN devices. This goes into some more detail of how those circuits work and the real space savings you can get compared to a bigger solution or an optocoupler solution for those isolated transceiver protocols. All of these are available on the web. You can search them by their names. They'll also be available in links like this after the webinar. Okay, and we won't have a live Q&A session today, but I did just want to mention, I know there's been a bunch of questions coming in on the chat, which is awesome. We'll try to answer a lot of those there today. But if you do have questions in the future moving forward, definitely take advantage of our E2E, our engineer-to-engineer support forum. So all of our product teams check this on a very regular basis, and it's something that we take very seriously to support your questions. So if you have any questions on any of our products, definitely go post them there and somebody will answer your questions very quickly.
Great. Thank you, Luke. And thank you, everyone, for typing in your questions. And we can stay on a little bit longer to help answer those in chat. But the presentation is finished for today. And please check back next Thursday. And you can see the link here where you can get all of our topics for the next coming weeks. Thank you. And we will have this webinar archived online at ti.com/NPU within the next few hours. Have a great day.